Okay, so let's go back all the way to the top in here. Okay, and compile it. Sorry, save it first. This ID is a bit annoying because when you don't save, it gives you some strange behavior. Okay, anyway, so let's see lang clang output will be called test2. Yep, test2. And the file name is test2.c. Okay, and let's run it. Test2. So dot slash test2. Okay, so let's dive in. First bit in here is our pointers. Okay, so we start in here. We created and assigned 10 to a integer variable, and then we created a pointer to an integer variable, and we assigned um, a value to it. Sorry, not the value, integer value, the address value. Okay, this is um, this guy here is an address notation. So you say, give me an address of this integer here and put that in here because I want to put that to a pointer. And pointer can only hold an address. Okie doke. And so we have it here. So let's have a look at plain old integer and pointer to an integer. So the address of plain old integer is something. A big number indicates that's inside of stack, but that's all you have to, you don't even have to know. It just has some memory. The memory starts from 0 and it ends at the very, last bit of memory. So if it's like 16 gigabytes, then it's like 16 billion bytes or whatever. That's how many cells it has. Obviously, it's a bit way more complicated, but it's easy to kind of visualize it that way. It just has a lot of bits, and they all have addresses from 0, 1, 2, 3, 4, and goes to that huge number here in hexadecimal. I don't know what that is, but it's huge. Um, Probably it doesn't start even at 0. It starts somewhere else, but let's not go in there. And its content is 10. So if we look in here, we asked for p in here. We put an address of integer in there, so that's fine. That means address, and then we put d in there, and we just put in the actual variable. Works, works. Here's the address. Here's the variable. I put that variable here. Sorry, the actual value of that variable, and that's 10. It's 10 in here. Works. Let's have a look at the pointer to an integer. So it itself has its own address. It needs to store it somewhere. So there's a bit of memory inside of stack that holds that address here. Yeah. So the content of this pointer is the address to what? To this guy. See, B7C, B7C. That's exactly the same. And even I'm highlighting this, and you can see a little box around it. That's exactly the same number. So that means all went right. I did assign the address of this variable to that guy, to this pointer, and it works. The content of that pointer is the address to here. Grand. And when I dereference it, I get 10. How do I dereference? So first I put in p because it's going to be an address, and I put that in here. Yes, that's an address of the pointer. And then I go to another address. I want to show another address, and that's going to be just the contents of that pointer, the content of the pointer variable. And at the very end, I said I want a digit at the end. I want to show some digit. And how to get a digit from that pointer, we want to dereference it. And we go to that plain old integer and we take the value from there. Okay, that's how you dereference. And this is your digit formatting, whatever. Okay, so that's done. And we have a string here. So let's go to here. I can see I made some little mistake there, but doesn't matter. Yeah, so this is how you declare a string. I know it's also we're declaring a pointer to a char, but that's how it is. This is two things in one. And strings themselves, they have their own kind of um, the way it's being handled by C, and it's a bit more complicated than the integer, for example. But at the end, it's just some sort of a functionality that you just have to memorize. So okay, so why so complicated, blah blah? we're going to put that in here. So we assign some string that I came up with. I have to put double quotation around it, otherwise it's not going to be seen as a string. I had to escape double quotations inside of my string, so it doesn't think I'm closing my string. It's just, yeah, I want to print that out actually. I want to store it in this case because then I want to print it out. And now in here, okay, so we're gonna print that out here, and it's here. Oh no, sorry, it's not a mistake. It's just a string's address is this. So again, a pointer needs an address. So that pointer to that char is residing in this bit of memory, and the content of it is this. It's an address to somewhere, and as you can see, it's a small number. It's a heap. It allocated, it malloced some address. So first, what it did, and it's funny how it works. It's very advanced actually. I'm so happy I don't have to do it. It takes all this string, it counts how many characters we have in there, and then it mallocates, it malloc size of whatever amount of cars we have in here, characters, chars, I don't know, chars or cars, and it multiplies it by the amount of them. So basically what it does is starts with y, let's copy this, put that in here. What it does is it does it like this, malloc size of. So we want to malloc some size, some memory, and the easiest way to do it is check what we're allocating there and just get the computer to calculate what is the size of memory we need. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 3, 4, 5. Say, okay, 30 characters there. 30, sorry, no. Car, and that's times 30. Yeah, so we're gonna have whatever is the size of a character. I think it's 255, so it's 4 bytes. 4 bytes times 30. So we allocate 30 bytes for that, and then we put that in one by one. Okay, one character by character. Okay. Anyway, so we did assign it there, and then we want to print it out. So first we check, okay, there is, for fuck's sake. Here's the address of a pointer that points at the first element of my string, the first character of my string, which is this. Then its content, oh, sorry, no. This address here is an address of a pointer. It holds this. It holds an address, and this address is an address of this element here. This element, we're gonna go to that element, and and here's the funny thing, look at this. If you use S in formatting, when you're formatting, and you use this, so see, I used no symbol here, just why so complicated strings, and I use that for this pointer here, and that makes sense because it is a pointer, so I just put that in there. But strings work like this. If you do it in exactly the same, just like you don't put star, ampersand, anything in there, and you use %s, it's gonna print out a string. And I know it's confusing, but that's the way it works, and just memorize it. You use char stars like this. You use this notation, %s, and you just put a name of the pointer. That's the name of a pointer actually. And that's how you get your string printed out. Okay? Have to memorize it, that's how it works. And then we want to dereference content using C. So I used %C as well. Okay? And I dereference. Now we have to dereference it. And it's actually, as I said before, our first element is the double quotation mark. Okay? So this is how string works, and it's a bit confusing. It's at the same time it's an array of characters, it's a pointer to characters, it's something kind of in the middle, but you can be sure computer knows what it does. It's not your problem. All you have to memorize is that you kind of work it that way. First, here's how you declare it, Here is how you assign it, blah, blah, blah. And here is how you display it. Okay. Okay, so let's go to double pointers now. So what is a double pointer? I think I tried to explain it in the previous video. It's basically a pointer to a pointer. So it's you have to say what is the last pointer pointing at, but then you can have as many pointers as you want, as long as at the end there's some sort of a content, some sort of a data type, some integer, float, maybe some structure that you created, but it has to have some actual value in there. It can't be just a pointer, address to address to address to address. At the end, there's nothing. It wouldn't work very well. So obviously you have to say we're going to be pointing at the very end at an integer, and here the amount of stars indicates how many pointers is there. Now we have two pointers. There's a pointer to an integer. Okay, and in here I put an address. I assigned an address of a pointer to that double pointer, and that's how it works. An address to a pointer is a double pointer itself, because this guy here, pointer to an integer, it points to an address of plain old integer. And then we take that address of that guy of pointer to an integer, sorry, and we put that in here. And that's how you create a double pointer. And it's very useful when you create functions and you want to pass by reference, and I'm going to explain why passing by reference is so powerful and passing by value isn't that powerful and can be very tricky and very disappointing when you want to do something more global. That's the word. You want to do a global change to your program, and function works on a local kind of basis. So you want to go outside of your local function to do some changes outside of that function, and that's why you use pointers. That's why you pass by reference, and sometimes you want to change something inside of the pointer, inside of a pointer. The value you want to change the value of a pointer. That's why you need an address to an address. Anyway, so let's have a look what that means. So we have a pointer to a pointer. So pointer to pointer to integer address is, so there's another address allocated for that specific variable that is a pointer to a pointer. It holds an address of our pointer that you can see in here. See, pointer to integer. Here's the address. It's in the box because I highlighted this. So that works. Okay, the content of my double pointer is the address to an integer, and then if we dereference um, oh yeah, no, sorry. So that's the address of the pointer, and that's the address of an integer, and that's the content of an integer. So first you have an address of the pointer of the variable that holds double pointer. Then this double pointer holds an address to a pointer, and if you dereference it, you go to this address, and this address here holds this value, which is a pointer again, which is an address again to an integer. Okay, it's not that complicated. It's just like going from address to address as until you get to some value. And sometimes you want to change something in the middle. You want to change just that address. You don't want to change the value. You want to leave that value there, and you want to just redirect our pointer somewhere else. That's why you need a pass by reference. If you have a function that does it, you want to pass by reference. Anyway, uh, and what happens next? Why it doesn't work? Passing by value. What is going on? Ah, yes, sorry. So this is the problem I'm having. So how many hours before bedtime? So we go in here and we are being asked. So this is how you pass by value. I created a function here that just takes some value, some integer, and it just prints it out. You don't want to change it. You don't want to go to that address and change it. You don't need to mess around with the memory. You just want to print something out. You just need a value to print out. It doesn't need a reference. So that's where you would use passing by value. So there is a local variable hours, and local means it's only in the function that it exists now, and it's main function. we are in main function here. In here we are in function value function. So, but in here we are in main function, and it's that variable here is local to main. So we are being asked how many hours to bedtime. Let's say here we're gonna answer that 5 hours. Okay, 5 hours. So we have 5 hours to prepare. Okay, to prepare for exam or whatever. So that's how it works. If I scroll down to my function that where I passed something by value, and I called it function value, you can call it whatever. And that's what it did. It took some value in here and made it local, so that int message is a local variable for that function. It can't be used anywhere else, and it's just printing something. But that's fine. We don't need to use it anywhere else. That's fine. It's void, which means it doesn't return anything. There's nothing, yeah, it doesn't return any value, any integer, character, anything. It's just like it does something and that's it. Okay? It just shows something or makes some change to some memory somewhere, but that's it. And that's how, yeah. Okay, so that's where our function with passing by value, and here we have passing by reference. So there is, for example, imagine you have a function, and that function holds an integer that calculates that holds in memory how many visitors we had, let's say today, as long as the program is running. So this is our, and it's very simplified. Obviously, this would be something completely different, but let's assume to simplify it. There is an integer called visits, and it holds 157 visits because that's how many people came in today. So we print out, yeah, today current visitors count is 157, okay? And then, sorry, we go in here. Oh, somebody came in. Okay, and we are running this function reference, and we pass an address of visits to that function. And after we pass that, after we run, we call this function and we pass the address of our variable that is inside of our main function. We can see we print pretty much the same message, but it's bigger by one. It's, you can see somebody added, my function added one to my visitors, and it wouldn't be possible if I didn't pass it by reference, because if I passed 157 in here, it would just take that value and it would do some magic in here, but it wouldn't do anything. You see, it doesn't return anything. It just changes something. In this case, this function here, it goes to that address, it goes to that local variable, but we have an address. An address is always absolute. So this visits is something that only main function here knows. That guy in here, that controls visits, and that specific visits, because you can have visits in here and you can have visits in here, yeah, and that means something completely different. In this code, visits is a pointer to somewhere, when in here visits is just an integer and it holds 157. So when we pass an address to this guy, we can tell this function, okay, go there, go to that function and add one, okay? And it did, and it went to that address, which is absolute for all the programs, and it changed it by one, and it's visible here. It's visible here, 157, 158, okay? Okay, and the last thing, I know it's long enough, so the last thing is a function that returns something. So in here, it returns void, nothing. In here, we have a function that returns an integer, and it's a very, very simple code. It's a very simple function, which is adds x and y and returns x plus y. That's it. That's all you need for a function that adds things. It's pretty useless because you could just use an add symbol. But anyway, if you look here, okay, so we are asking for integer a, integer b, and we are adding it using this function, and we can assign. See, I use that function here, adding function a and b. I pass those two values, those two integers by value I don't need to give their addresses. It's fine. So I just pass them by value here, and it adds them together and assign that sum to C. And you can print that out, and you can see it here. So let's add 4 and 8. Okay, so it added 4 and 8. It assigned it to C, and we print 12. And that's what's happening here. We are printing C, and C is coming from here. Okay, but we also can um, put that in. It's basically like an integer there. It assumes there's going to be an integer. You can write 10, you can write a, or you can put in a function in there, in here when you're formatting your printf, and you can say, hey, listen, computer, there's going to be a number there, and I want to put it in here. You see, I told you it's going to be a number, so just use that number, whatever that is. And it could be a function, it could be a variable, it could be just a number. But in this case, it's a function, and as you can see, it adds a and c. 4 and 12 is 16, and it's indeed 16. Okay, thanks for watching. I know it was long. I hope I'll have time to go through stacks and queues today. But I hope it also clears a couple of things for you before you go to stacks and queues. Um, like the main thing is the pointers when it comes to stacks and queues, and how you have, in your main function, you would have like a pointer to the front and back of the queue, and you need somehow to take it to your function and manipulate those addresses. So you need to pass it by reference, and that's how you put your hands on double pointers. Okay, thanks for watching, and see you soon.